Now we will see important results of exponential series. Since we know that e raised to the power x is equal to 1 plus x upon factorial 1 plus x square upon factorial 2 plus x cube upon factorial 3. If I replace x by minus x, then everywhere if I replace x by minus x, I obtain first result, which is e raised to the power minus x is equal to 1 minus x upon factorial 1 plus x square upon factorial 2 minus x cube upon factorial 3 plus and so on up to infinity. Here if I replace x by minus x, then first term will remain 1 as it is, then x is replaced by minus x, so here the second term will become negative, that is minus x upon factorial 1. Then in third term x is replaced by minus x, so minus x whole square will become again plus x, so third term will be x square upon factorial 2. It will be a positive term, and then again I will obtain minus term. So this way I obtain the signs of the term as first term is plus, second is minus, third is plus, fourth is minus, then next is plus, and likewise. Now if I put x as 1, then this first result which we have obtained will become e to the power minus 1 is equal to 1 minus 1 upon factorial 1 plus 1 upon factorial 2 minus 1 upon factorial 3. X is replaced by 1. So if I write x as 1 in this result, I obtain this result. Next is e to the power x we know is 1 plus x upon factorial 1 plus x square upon factorial 2 plus x cube upon factorial 3, and e raised to the power minus x we have seen is 1 minus x upon factorial 1 plus x square upon factorial 2 minus x cube upon factorial 3. If I add both the equations, I obtain e raised to the power x plus e raised to the power minus x will be equal to 2 times 1 plus x square upon factorial 2 plus x4 upon factorial 4 plus x raised to the power 6 upon factorial 6, and so on. Here by adding I find that this second term is cancelled in addition. Again this term x cube term is cancelled, and I obtain 2 times 1 plus 1 is 2 times, so 2 I have taken common already, so 1 in bracket, then again 2 times of x square upon factorial 2, so 2 I have taken common, so it will be x square upon factorial 2, and likewise the other terms I will be obtaining. Now 2 can be taken to left hand side under division by cross multiplication, so e raised to the power x plus e raised to the power minus x upon 2 is equal to 1 plus x square upon factorial 2 plus x raised to the power 4 upon factorial 4 plus x raised to the power 6 upon factorial 6. That is, here I obtain every term positive and the powers of x are even powers. The powers of x are all even powers, that is 2, 4, 6, etc. Odd powers are eliminated. Again, if I subtract these two equations, that is first is e to the power x and second is e to the power minus x, then I obtain e raised to the power x minus e raised to the power minus x is equal to 2 times x upon factorial 1 plus x cube upon factorial 3 plus x raised to the power 5 upon factorial 5. Because in subtraction, then 1 and this 1 will be cancelled. X square upon factorial 2 will be cancelled by this x square upon factorial 2. So I will be obtaining the odd powers of x, and 2 times of course, because here x upon factorial 1 and this x upon factorial 1 will be added. Again, if I bring this 2 to the left hand side by cross multiplication, then I obtain e to the power x minus e to the power minus x upon 2 is equal to x plus x cube upon factorial 3 plus x raised to the power 5 upon factorial 5 plus and so on. This is up to infinity. So here I obtain odd powers of x. here in this expansion I obtain odd powers of x. Now in these two results, that is this result and this result, if I put x as 1, then I can comfortably write e plus e to the power minus 1 upon 2 is 1 plus 1 upon factorial 2 plus 1 upon factorial 4 up to infinity, and e minus e to the power minus 1 upon 2 is equal to 1 plus 1 upon factorial 3 plus 1 upon factorial 5 up to infinity. So this way we see the important deductions, or we can say important results in the expansions of the exponential series. These results we will be using frequently while solving the questions. Here we should also remember few things. First is e raised to the power minus 1. The value is 0.36667. Factorial 0 is taken as 1, and 1 upon factorial minus n is equal to 0.